Aloha, Assalamualaikum and good day everybody. Today we are going to learn chapter 2, factors and multiples. The learning standard that you need to achieve is at the end of this lesson, students should be able to determine and list the factors of whole numbers, hence make generalization about factors. Prime numbers is a non-zero whole that can only be divided by 1 and by itself. 1 is not prime number. 2 is the only even number in prime number. This is an example of prime numbers to 100. 2, 3, 5, 7, 11, 13 and so on. What are factors? Factors of a number are numbers that can divide the number completely. Example, 12 can be divided completely by 1, 2, 3, 4, 6 and 12. Therefore, numbers 1, 2, 3, 4, 6 and 12 are known as factors of 12. Example 1. Determine whether 12 is a factor of 36. How can we determine whether 12 is a factor of 36? Solution: 36 divided by 12 equal 3. Thus, 12 is a factor of 36. When we divide the number can be divided completely. That is the evidence that the number is a factor. B. 9 is a factor of 30. Solution: 30 cannot be divided completely by 9. Thus, 9 is not a factor of 30. You can now take out your calculator and try to divide 30 by 9. You will get the answer that will have a remainder. So 30 cannot be divided completely by 9. Thus, 9 is not a factor of 30. Example 2. List all the factors of 18. Solution: 18 equal 1 multiplied by 18. Thus, 1 and 18 are factors of 18. 18 equal 2 multiplied by 9. Thus, 2 and 9 are factors of 18. 18 equal 3 multiplied by 6. Thus, 3 and 6 are factors of 18. Therefore, factors of 18 are 1, 2, 3, 6, 9 and 18. Don't forget. What are prime factors? Prime factors of a number are factors which are also prime number. Factors of 18 are 1, 2, 3, 6, 9 and 18. Among these factors, 2 and 3 are prime numbers. Thus, 2 and 3 are known as prime factors of 18. Example 3. Determine whether each of the following numbers is a prime factor of 84. A. 2. Solution: 84 divided by 2 equal 42. 2 is a prime number. Thus, 2 is a prime factor of 84. B. 3. Solution. 84 divided by 3 equal 28. 3 is a prime number. Thus, 3 is a prime factor of 84. Let's look at C. We need to determine whether 5 is a prime factor of 84. Solution. 84 divided by 5 equals 16. Remainder 4. 5 is a prime number, but 84 cannot be divided completely by 5. Thus, 5 is not prime factor of 84. What are prime factors? Example 4. List all the prime factors of 72. Now we need to list all the prime factors for 72. How can we list all the prime factors for 72? Solution. First step is to list all the factors of 72. Okay, factors of 72 are 72 equal 1 multiplied by 72. 72 equal 2 multiplied 36. 72 equal by 3 multiplied by 24. 72 equal 4 multiplied by 18. 72 equals 6 multiplied by 12. 72 equals 8 multiplied by 9. You can use a calculator to divide 72 by 2 and then 72 by 3 and so on to get the factors. 1, 2, 3, 4, 6, 8. That is how you list the factor of 72 from the top to down and list it as in the factor of 72. Next, from down to top. From bottom to top. Okay, those are the factors of 72. Okay, 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36 and 72. Second step is identify the prime numbers from the list. From this list, you need to identify the prime numbers. Okay. Prime numbers are 2 and 3. Thus, the prime factors of 72 are 2 and 3. What are prime factors? A number can be expressed in the form of prime factorization, in which the number is written as the product of its prime factors. For instance, 18 equal 2 times 3 times 3. Prime factorization of a number can be done by repeated division by prime numbers or by using a factor tree. Okay, let's look at example 5. Express 60 in the form of prime factorization. Let's look at the solution. Okay, this solution is going to use method of repeated division. Let's look at how we can solve it using method of repeated division. First, perform division repeatedly by dividing with the smallest prime number. The smallest prime numbers is 2. So we need to divide by 2. Okay, draw this vertical line, straight line, and next draw this horizontal line. Okay, on the line on the right side, you write the numbers that are given in the question, 60. So, and use divide by the smallest prime number, which is 2. 60 divided by 2 is equal 30. Then, you draw another horizontal line. 30 divided by 2, again, repeatedly divide by smallest prime number. 30 divided by 2 equal 15. Okay, 15 can divide by 3, also prime number. The larger prime number after 2. So you use 3. 15 divided by 3 equal 5. Next, divide it using another prime number. 5 can be divided by 5 equal 1. You do the division until the quotient is 1. Repeatedly doing the division until the quotient is 1. Okay, and remember, you must divide with a prime number from the smallest prime number. Thus 60 equal 2 times 2 times 3 times 5, the one from the left. Okay, next we are looking at the same question, example 5, but using another method. The solution this time is using the method of drawing a factor tree. Okay, first you need to write the number of the question, 60. Okay, then what multiply what number to get 60? Okay, example here, 4 multiplied by 15 equals 60. Okay, next, 4. What number can multiply with what number to get 4? 4, we divide by 2, you will get 2. Or 2 multiplied by 2, the answer is 4. And 15. 3 multiplied by 5 equal 15. Thus, 60 equal 2 times 2 times 3 times 5. The one that I circle in green color. Okay, that is the prime number. Okay, and you write it, you write all the prime number such that 2 multiplied by 2 multiplied by 3 multiplied by 5. Okay, or you can use another 3. Okay, like this, 60 equal 2 multiplied by 30 is also 60, and 2 is already the smallest prime number, so you should do nothing to 2 anymore. You just bring down number 2 in the 3 figure. Okay, 30, you can multiply 3 by 10 to get 30, and 3 also, 3 here also is a prime number already. So you just draw the 3, bring it down like that. Then 10, you need to solve. What multiply what number to get 10? 2 multiplied by 5 equal 10. All this here, 2, 3, 2, 5 are all prime numbers. So the prime factorization for 60 equal 2 multiplied by 2 multiplied by 3 multiplied by